Let's zoom and focus on two main icy satellites of the Jovian system, which are Europa and the biggest Ganymede. So now let's talk about their geology and their tectonics. So Europa is a prime candidate for extraterrestrial habitability in the solar system. And its icy crust has an unknown thickness that still represents an open issue for the scientific community. Generally, it is thought that it has a thin crust of maximum tens of kilometers, but some works assume also a more thick crust of nearly 100 kilometers. But we still don't know. And below its icy crust, it is assumed to occur a global ocean, as I already said, and a rocky mantle. A rocky mantle where at the contact with the ocean possibly can occur hydrothermal vents that can potentially host forms of life. So we will concentrate to the crust and the surface of Europa. The global mosaic based on the Voyager and Galileo mission data shows a very complex geology that characterizes a surface whose composition has been measured thanks to data of spectrometer of Galileo mission. That is the near infrared mapping spectrometer, NIMS, which perform spectroscopy acquisitions from 0.7 to 5.2 micrometers. And the authors carried on spectral modeling that you have learned during the seminars of the first day. Yes, on Monday, there were some seminars about spectroscopy. So this is the map, for instance, of the abundance of water ice in the surface of Europa. And here, blue areas indicate stronger absorption bands that generally implies higher water ice abundance, while the red areas indicate reduced water ice abundance. And so thanks to spectral analysis, we have also models on spatial distribution of estimates of other compounds such as salts abundance in the surface of Europa that also follow different pattern according the latitude and also according to the main geological unit. So yeah, such a composition can be related to the geological units and features that characterize the geology of the surface of Europa. And so the global mosaic based on Voyager and Galileo data shows a global scale linear to curvilinear structures that cross-cut the whole surface, which at first sight seem to follow a very chaotic pattern. And such mosaics is base map has been required as base map for global scale mapping that is useful to study the geology and also will be used for future studies for Europa's geology. So a global scale geomorphological map has been produced according to variable lighting conditions and image resolutions from the base map Voyager and Galileo mosaic. And this map, the global and regional scale geological map of Europa, recognizes units that includes craters, caves, bands, and also regional plains and lineaments, mostly lineaments that include deformation structures such as ridges, trough, lineament, lineae, and cycloids. So this map shows the relationships of the tectonic structures and their interaction with each other at a global scale. And of course, this global view allows us to better understand the geology of Europa, but also to start formulating more and more questions about terrain formations. So the main terrains of Europa are the ridge plains that are generally bright areas transected by linear features and tectonic structures. And the other terrain is the mottled terrain. It is a darker unit of disrupted icy material that is superimposed on the older plains, and it has been formed by the disruption of the older plains. And so both terrains are dissected by a large amount of linear structures and also circular surface features. The simple landforms on Europa, on the surface of Europa, are individual linear to curvilinear trough that are isolated fractures which have been formed by extension, so the stretching of crustal blocks. While the most ubiquitous landforms recognized on Europa's surface are the ridges, or better, double ridges that can then form a ridge complex as shown by the orange arrows in the figure. So ridges occur across every sector on Europa, on this body. But unfortunately, their formation is still poorly understood. There are current hypotheses providing several mechanisms for the development of the distinctive morphology. So for instance, the formation mechanisms for ridges are tidal squeezing that assumes their opening and closing in response to changing tidal stresses. So this process allows to the deeper material to arise and contribute to build the rims of the ridges. But then also there is the model that assumes linear volcanism, which suggests that such structures are volcanic constructs, while other authors assume also the formation by intrusions of meltwater or compression mechanism that propose that ridges are contractional structures. And then other works that assume that they have formed by diapiric rise of warm ice that have uplifted the surface by forming the ridges. And the last mechanisms that suggest that such structures are strike slip structures created by frictional heating. So another ubiquitous features that characterize Europa's surface are bands that represent smoother terrains of low albedo and are assumed as extensional structures whose opening has led to infilling of dark material and whose reconstruction implies that the surface of Europa has behaved in a brittle manner and is characterized by rigid plates, if we can say plates, rigid, something similar to rigid plates, has our plate tectonics. But also some bands show also a significant strike slip component, suggesting sometimes oblique opening. So not always a pure extension, but an oblique, yes, an oblique stretching and opening of these deformation zones. And the surface of Europa is also characterized by particular structures called cycloids that are chains of arcuate ridges connected all together. So their formation is assumed to be linked from tension in response to tidal stresses that cause the formation of fractures that are perpendicular to the direction of the tensile stress. But of course, the tidal stress changes, and in turn, also fractures vary their propagation across ever-changing stress field. So the propagation follows a curving path until it reaches a location where the tensile stress is insufficient to continue the propagation. So when the stress at the end of the fractures once again allow the fracturing, the propagation will continue with a direction that is perpendicular to a new orientation of the tensile stress. And the location where the curve ends, there is it happened a reorientation of the tensile stress. So the location of this change of reorientation of the tensile stress is called cusp. Here it is shown by the red circle, this figure. And so substantially shows the period when the fracture is inactive. So as I said, Europa is the unique icy satellite that has shown few evidence for contractional structures. Folds are structures created by deformation of the crust due to compressive stresses that lead to the bending, to the folding of the crust. So this is an example that suggests the occurrence of such features, folds, where set of that is evidenced by sets of troughs and ridges that occur in the same location of fold axes. Fold axes are the location where the maximum curvature of the fold is reached. So such cyclic occurrence of trough and ridges has been interpreted to as the brittle fracturing associated to the curvature of regional scale folds, so a regional scale compressional activity. So to end such overview of features of the surface of Europa, I would also add the main features formed by mechanical processes and not only by tectonics of the surface of Europa, such as the chaos regions, which mostly characterize the molten terrain and are characterized by polygonal blocks of disrupted icy material that has been broken and shifted around. So chaos have formed by possibly an increasing of the heat flow, and so also maybe local melting that led their disruption into feature similar to our iceberg, to the iceberg that we see on Earth. And another puzzling feature that characterize the surface of Europa are the lenticulae, which are round to elliptical structures that characterize domes, pits, and spots with a low albedo. The formation of lenticulae concerns horizontal intrusions of water on the subsurface layer within the crust, within the icy crust of Europa, that cause fractures and their propagation to the surface until the disruption of the surface. And according to the thickness of the lithosphere, so it can occur a downward flexure that produces pits if the thickness is sufficiently thin, but also domes if the lithosphere, if the crust is more thick. So all the features that I have just show you are the main structures that you can identify at the surface of Europa. So as you saw, the geology of Europa is very complex. It's not easy to reconstruct the pristine form of some areas, pristine settings of some areas, since most of them are very disrupted and deformed. But I will show you an example of structural mapping and tectonic reconstruction on Europa. In this work, the authors have proposed a model similar to our plate tectonics that affect the crust of Europa. So they mapped the main units of their study area and the main tectonic structures. Here is the current situation that has been mapped by the authors. They recognize similar units at north and south to these approximately east-west structures that occurs at the center of the map on black. And thanks to kinematic indicators and the occurrence of similar units that have been separated by this main east-west structure, so this mapping allowed the authors to reconstruct the pristine setting of the area. So they restore the tectonics starting from structural mapping. Indeed, such east-west lineament at the center of the area is a strike-slip structure whose kinematics shift westward the block at the north of these structures. And the reconstruction of its kinematics, it has shown, so this is today and in the past, the kinematics of such structures, the restoration of such structures, kinematics is something like that. Such reconstruction show a missing area that has been interpreted to be subducted below the surface, such as our subduction zones on Earth. The authors so interpreted that potential convergent boundary occur on such study area that truncates abruptly older geological features and show, therefore, the evidence of compression on Europa and therefore plate tectonic-like system of brittle surface above warmer ice. So this is a nice example of geological and structural mapping that has been pivotal for identification of compression on Europa. So this work explains how this is on the right, the model that explain how and where the missing material went. And it undergoes downward under the icy crust, similar to similarly to what happened on subduction zones on Earth that move downward on the rocky crust. So on Europa, such structures differ from the subduction plates. Of course, since they don't sink, they don't really sink, but instead they are incorporated within the icy crust. And this model is called subsumption, and so shows that Europa may be the only solar system body behind the Earth that exhibits a possible system of plate tectonics. Also, others show models similar to plate, also other planetary bodies show similar plate tectonics model.